We tell our AI assistants what to do all the time. But how can we actually be sure they're going to listen every single time? Today, we're going to break down the huge shift from just asking AIs to follow the rules to building a system where they literally have no other choice.
Okay, let's just dive right in with this quote, because it perfectly gets to the heart of the problem. When you give an AI a file with instructions, you're not giving a command. You're hoping for the best. And look, that might be fine for some casual stuff, but when you're trying to build professional-grade software, hope is just not a strategy. You need certainty.
All right, so to really get a grip on this, we've got to start with how things are done right now. This is the world of suggestions, not commands.
So, lots of developers use these files, right? You'll see Claude.md, .cursor rules, Gemini.md. Think of it like a briefing doc or a cheat sheet you'd give to a new teammate. It's meant to get the AI up to speed on all the project's little details and rules automatically every time you start a new session. And the idea is, honestly, brilliant. You write down all your rules in one central place, so the AI behaves consistently. It should know all your project's unique quirks, like how you name things or your specific testing procedures. And the best part is, you don't have to keep repeating yourself in every single prompt. It's all about making things efficient and consistent.
But, and this is the big but, these are just polite suggestions. There is literally nothing that forces the AI to obey. It's basically an honor system, and as we're about to see, an AI can be, well, less than honorable with the rules.
So, let's talk about what happens when this honor system breaks down. This is where the prayer often goes completely unanswered and the real-world frustration kicks in.
This comment from a developer on Reddit, I think it hits home for so many people. The AI might follow a rule perfectly one day, but then, as the conversation goes on, it just gets comfortable. It starts skipping steps or completely ignoring instructions it was following just minutes before.
And this nails the core issue, doesn't it? For anyone in software development or really any professional field, consistency is everything. This kind of unpredictability, where you can't trust the tool to do the same thing twice, is an absolute nightmare.
Researchers actually have an amazing name for this. They call it vibes-based execution. And it's perfect. It basically means the AI follows the rules depending on its current vibe. Its internal state, how long the conversation is, how complex the task is, instead of following a strict, unchangeable set of instructions. Okay, so if suggestions are just too flimsy, what's the fix? Well, we have to move from just hoping the AI listens to creating a system where it has no other choice. It's time to go from suggestion to law.
This slide really breaks down the massive shift in thinking. The old way is all about natural language, which is fuzzy and probabilistic. It relies on hope. The new way is built on a compiled language, on pure code. It's deterministic, it's verifiable, and enforcement is absolute. It's the difference between ambiguity and certainty.
And this new approach is being brought to life by a framework called Clotho. It's actually named after one of the Greek fates, the one who spins the thread of life. And it's fitting, because once a rule is defined in Clotho, it becomes the agent's destiny. It's not a suggestion anymore, it's the law. So how in the world does Clotho actually do this? How does it build this unbreakable wall between what an agent wants to do and what is forbidden from doing? Let's get into the mechanics.
This table shows the evolution perfectly. Your standard.md file is just natural language. It's got variable reliability. You move up to basic permissions, which might use simple text matching. Better, but still pretty easy to trick. But then you get to Clotho. It uses a proper compiler architecture, just like a real programming language. And that's the key. That's what allows its reliability to be absolute.
The process is basically a three-step dance. First, you define your rules in a special .n2 file. Second, a compiler takes those rules and turns them into a logical blueprint, something called an abstract syntax tree, which makes sure the rules are crystal clear and can't be misinterpreted. Finally, that blueprint gets turned into a digital firewall that actually enforces the rules while the AI is running.
This is my favorite way to think about it. You know the old saying, don't think of a pink elephant? Which of course makes you think of one. Prompting an AI is like that. But Clotho isn't prompting, it's building a wall. It makes it physically impossible for the agent to take a forbidden action, the same way a brick wall makes it impossible for you to just walk right through it.
Now, Clotho is the foundation, but it's not the whole building. It's actually part of a much larger ecosystem that's designed to solve some of the other really big problems with today's AI agents.
So the N2 ecosystem builds right on top of Clotho. You've got Arc, which is like a security guard, using Clotho's rules to block bad actions. You've got Soul, which tackles the AI's terrible memory problem. And then there's Arachne, which smartly figures out exactly what context the AI needs to see, making it way more efficient. Each piece is solving a very specific, very common failure.
And here's what's absolutely crucial. This whole system is model agnostic. Because the enforcement happens outside the AI model itself, you can apply the exact same set of laws to Claude, GPT-4o, Gemini, you name it. This means you can finally have unified governance and let all these different agents work together without worrying about security holes.
So, what does this all mean for the future? Well, this shift towards verifiable, deterministic AI behavior has some pretty huge impacts, both for our tech and for our wallets.
Okay, get ready for this number. By having a system that can intelligently manage what the AI sees, like that Arachne component we just talked about, developers have seen token savings of up to 98.5%. That's not a typo. And that translates directly into lower API bills and way faster response times.
And the best part? Getting started with this is way simpler than you might think. You don't even have to learn this new .n2 language yourself. You can just write down your rules in plain English, just like you would in a .md file, and then ask the AI to translate it for you. The AI literally writes its own legally binding contract.
And this all brings us to the big question we really need to be asking ourselves. We are building these incredible 1,000-horsepowered AI engines that can do amazing things. But up until now, have we really been building brakes that are just as sophisticated? Or have we been trying to stop a race car with paper suggestions? Frameworks like Clotho are the answer. They represent that sophisticated, reliable braking system that we desperately need. This transition, from vibes to verification, is what's going to let us steer the future of AI safely and, most importantly, predictably. Thanks for watching.